Welcome to homecampus.com.sg. Let's find out what the area of a triangle is. Okay, so what I'm going to do first of all is I'm going to make a rectangle here, and from that we'll derive the formula to find out the area of a triangle. Okay, so here is a rectangle. Let me call this rectangle, say A, B, C, D. Okay, so I have a rectangle A, B, C, D, and just like any rectangle, it's got a length, which is the longer side, and a width. Okay, next what I'm going to do is I'm going to cut this rectangle into two. Okay, into two triangles. Okay, so this is how I'm going to cut the rectangle into two halves to make two equal triangles. Okay, now here is my first triangle. If you can't see that already, here is a triangle, and here is another triangle, right? So this rectangle is made of two equal triangles, and just to be more specific, this is a right angle triangle, and so is this, right? This is triangle 1 ABC, and this is triangle 2 ADC. Okay, so these are two triangles which are made of one rectangle. Now from here, can I calculate the area of one of the right angle triangles? Actually, it's pretty simple. Okay, this symbol means right angle. So the area of one of the right angle triangles, let's say ABC, is obviously half of the area of rectangle ABCD, right? Half of the area of rectangle. That's what the area of one of the right angle triangles is, because two triangles make one rectangle, so one triangle is obviously half the rectangle. So there you go, half of the area of rectangle. What is that? Well, it's half of length, this length BC, times the width, which is AB. Length times width is the area of rectangle, and half of length times width is the area of triangle ABC. Now, when we talk about triangles, we don't talk about length and width. What we do talk about is another thing, two other things called base and height, which we learned in a previous lesson. So if we consider this triangle ABC, okay, this triangle ABC, and if we call BC as the base, if we take BC as the base, let me call this the base, then we know that the height of this triangle would be the side that's perpendicular to the base, and in this case the side that's perpendicular, or the line that's perpendicular to the base, is AB, which is the width. So as simple as that, the height of this triangle is AB. Now in this formula, if you replace the length by the base and the width by the height, what do you get? Well, what you get is this: half of means multiplied by, half of base times the height. And there you go. That's the formula to calculate the area of a right angle triangle. A right angle triangle, its area is equal to half of its base times its height. As simple as that. Okay, so that's done. The area of a right triangle is taken care of. But what about any other triangle? What if it's not a right angle triangle, and if it's any other triangle, say like, you know, a regular triangle, then what about its area? So let's see. Actually, you'll learn that the area of any triangle is half of its base and height. But we'll see. Actually, I'll show to you how that is true. Okay, so what I'm going to do is I'm going to take a grid first, and I'm going to make a triangle inside this grid. Okay, so let me make a triangle here in this grid. Okay, so say this is the base of the triangle. It's quite light, so draw it again. Okay, so here is the base, and let's see, these are the other two sides. Okay, also let's fill in some color. Okay, now here is what I'm going to do. This I know is my base. I'll write that down actually. This is the base. Okay, and the height of this triangle is this line, right? From here to here. This is the height. This is the height. And I want to show to you that the area of this triangle ABC is half of the rectangle made by the base and the height. So actually let's first make the rectangle that's made of the base and the height. So this is the base, so that's one side of the rectangle. Then this line is the height, right? The height is this and so is this, because these two are parallel to each other. So that's the height, and this is again the base and the height. Okay, so here is my rectangle made of the base and the height of this triangle, and I'll show to you that I can fit this triangle ABC into half of this rectangle. Let's call it some let's give it some name, say PQRS. So the area of triangle ABC, will see that it's equal to half of the area of the rectangle PQRS, and PQRS is the rectangle made of the base and the height. Okay, so let's do that. Actually, I will cut this part of the triangle, then I'll rotate it here and I'll place it here. It fits here. Then I take this part of the triangle, I turn it again and I place it here. So there you go, the triangle ABC can fit into half of this rectangle PQRS. So if the area of the rectangle is base times height, then the area of the triangle is half of base times height. And this is the same as what we saw before. This over here, the area of right angle triangle is also half of base times height. And you can take any triangle and prove that its area is half of the area of the rectangle made by its base and height. If you take, for example, a triangle like this, say an obtuse triangle, say something like this, something like this, fill in some color. Okay, now this is the base, this is the height, and this is the rectangle, okay, made of the base and the height. And I'll show you really quickly that the area of this triangle, this purple triangle, is equal to half of the area made by this rectangle, which is made of the base and the height, right? The height of this triangle is this, right? This one over here. This is the height because it is perpendicular to the base, if you extend the base, right? Now let's see, if I cut this triangle here, okay, and I move it here, then I take this part of the triangle and I will actually need to rotate it so I can fit it, and I fit it into here. Then you see again, its area is half the area of the rectangle made by the base and the height. So there you go. The area of the pink triangle is also half of height, because it's half the height times the base. But we usually write it as half of base times the height. It's one and the same, doesn't make a difference because these are all the same operations. Okay, that's it. That's all I'm going to talk about in this lesson. I hope you've understood it, and I hope that now you'll go and practice some exercises at www.homecampus.com.sg. Don't forget to practice, because practice makes perfect. This is Em signing off for now. Bye.
You know pi is the ratio of the circumference of a circle to its diameter. So how far around a circle divided by how far across gives you pi. And ever since people first started to think about mathematics or geometry, pi pi has been one of the most fascinating of all numbers and applies in so many other areas of mathematics and geometry, of engineering, of physics, and it's driven some people absolutely mad in their attempts to understand it.
Mathematical disc jockey Adam Spencer is a big fan of pi, a number that appears in the weirdest places. For example, take the sort of windy rivers that flow across gently sloping plains. It's not exactly clear why, but measure the actual length of a river, divide it by the distance from source to ocean as a crow flies, and the result is, on average, pi, 3.14. Pi. It's a God-given number, and it appears everywhere from probability to pendular, as pointed out by maths enthusiast Rob Easterway. Oh, and by the way, L over G is pendulum length divided by the acceleration due to gravity.
The pendulum's swinging quite free, then it's always a marvel to me that each tick plus each tock of the grandfather clock is 2 pi root L over G. Now maybe it's not such a surprise that in a pendulum you've got pi, because after all a pendulum is a fixed stick and it's creating a bit of an arc of a circle. But there are other situations where you'd think this surely hasn't got anything to do with a circle. Let's suppose we're on a really big sandy beach on some desert island, and you've got a very large rake, and each of the teeth of the rake are exactly 1 inch apart, and you just run this rake along the beach, and you can imagine you've created lots of parallel lines. And you happen as well to have a matchstick which is exactly 1 inch long, and you decide to start tossing this matchstick, landing it on your parallel lines. Well, if you do this experiment thousands of times, the chance of landing on one of the lines is exactly 2 over pi if you conduct the experiment completely randomly.
Pi r squared gives you the area of a circle, but where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius, so height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.